Hello, my name is Rishi Podar, and I'm a project manager with Peterborough Utilities. Welcome everyone to this virtual tour of the Campbellford-Seymour Generating Station. The Campbellford-Seymour Generating Power Plant is located on the Trent River, a few kilometers north of the town of Campbellford. Peterborough Utilities owns and operates two plants at this location. Plant 1 is a heritage power plant constructed more than 100 years ago in 1910. It incorporates two horizontal Camelback Francis turbines with a total power output of 2 megawatts. Plant 2 was completed in 1994 and incorporates two S-type Kaplan turbines with a total output of 4 megawatts. Both plants are located on federally owned property. Parks Canada and Trent River Waterway own and operate the locks 14, which is just adjacent, as well as the dam. Campbellford was one of the first municipalities in the province to have its own generating station. When Trent River Waterway Canal was built in the early 1900s, Campbellford was given the right to use the surplus water at Crow Bay to generate electrical power. Plant number 1 was constructed at this time, and the power was wheeled to the town of Campbellford, where it was used by local residents, commercial business, and industry, including several large mills. The new construction of Plant 2 tripled the capacity from 2 megawatts to a total of 6 megawatts at the Campbellford-Seymour plant. Plant 1 has two Camelback Francis turbines. The Camelback is a unique design where there are two inflows. The first inlet is on the back of the first hump and creates a force opposite to the river flow. The second inlet is on the front of the second hump and balances the force so there is no thrust on the shaft. Plant 2 has two Type S Kaplan turbines manufactured by Alstom. These turbines are double regulated, first by wicket gates and then by controlling the pitch of the blades. This allows much greater control of the turbines to achieve the correct speed and thus contributes to the greater efficiency of the Kaplan design. The synchronous generator in the Plant 2 are manufactured by Cato Engineering. The generators are connected through a gearbox, which increases the speed from 178 RPMs to 900 RPMs to reach the grid synchronicity. Although this speed is required to reach the grid synchronicity, it creates a lot of losses. The gearbox loses a lot of heat due to friction. We have two large radiators to dissipate the heat and keep the oil cooled. We have recently installed vibration and temperature sensors, as well as an oil analysis system to provide real-time data and allows us to perform targeted maintenance. In the past, we would complete routine maintenance on a quarterly basis, but with the new oil monitoring system, we do not need to change the oil until we see the degradation in the oil. This allows for a much more targeted maintenance as well as a greater longevity of the equipment. At the end of 2020, we also installed an 80 kilowatt backup engine. The engine supplies the Master Control Center located in Plant 2, which also supplies Plant 1 station service. Based on the interconnection, before the backup engine was installed, an outage at Plant 2 would also require the shutdown of Plant 1. We are now able to continue running Plant 1 even if the grid connection to Plant 2 goes down. We currently have a PLC system in Plant 2 for the remote monitoring SCADA operations. Although the system has been here for many years, our primary method for remote access was through the HMIs. We have since connected Plant 2 directly and looking to replace the PLC system to provide greater control, alarms, and monitoring. We currently still connect to the HMI in Plant 1, but this will also be updated when the new PLCs are installed. Plant 1 was originally commissioned to service the town of Campbellford. It was Campbellford POC that owned the original plant and wheeled power to the town. Over 100 years later, POI, through its subsidiary, Campbellford-Seymour Electric Generation Inc., continues to wheel power to the town on the 4.16 kV feeder. In 1994, when Plant 2 was constructed, it was connected to the Havelock TS 44 kV feeder based on the higher output capacity. thus have two transformers in our substation, one connecting to the Campbellford DS and the other connecting to the Havelock TS at 44 kVs. As our transformers are oil filled, we have also installed a secondary containment system, which is a membrane which absorbs the oil but allows the water to pass through. The location of our powerhouse is directly adjacent to the lock, which is an added concern due to the higher traffic potential. To ensure public safety, we have created a well-defined perimeter around the plants, including boom lines in the water at the intake canal and the tail race, as well as fencing along the grounds adjacent to the plant on both sides. We have included bright, clear signage at key locations to further inform and protect the public, as well as high visibility markers and audible alarms in the event of an emergency. The operation of the dam is also very critical with regard to the river flow. Normally, with the run-of-a-river operation, any disruptions at the turbine is managed by opening gates up to the maximum flow. However, at the Campbellford plant, we do not have a dam structure with gates, only an ice sluice gate, which is primarily used to pass debris and ice in the winter. Given the close proximity to the next plant down the road, we have a very narrow communication bandwidth with Trent River waterway. We must notify them immediately of any changes in load that will impact the flow. They will make the necessary changes at the dam to ensure that the water levels stay at a safe level. I want to thank you for joining me on this tour. I hope you enjoyed the information that I had to share, and I look forward to meeting all of you in the future. Thank you once again, and have a great day.